Hello, William Rose. I just completed my Lab 2 chemistry of fireworks, and so I was going to do a recap, summary, self-reflection, critical thinking as well. So I'm just kind of finishing up. I got most things cleaned up. I saw my chemicals and these little, what do I call them, inoculating loops. So as far as the lab went, I feel like everything went really well. I utilized the wavelength and nanometers linear diffraction gradient scale. And basically I kind of came up with the following results. So the lithium chloride I had as kind of purple. I got some purple on a few, but I retested that one quite a few times and then ended up getting red, which I know red and purple are kind of on the opposite sides of the scale. But when I was able to get a valid sample, I got red, and I ranged coloration from about 650 to 700 nanometers. Let's see, the sodium chloride I had coming in between 585 and 650 nanometers. I got a lot of a yellow coloration on that. Third, which I had the potassium chloride, and I was getting bluish purple coloration between 410 450 nanometers. And then lastly, I had the calcium chloride, which I was getting about 640 to 660 nanometers for coloration, which was orange in color. So as far as the biggest safety hazard went, I didn't really feel like there was any safety hazards. I did have the metal platform that came in the lab kit. I isolated the candle off of that just because I didn't want to utilize the plastic table. Other than that, I had the glasses and then the apron and stuff that came with the kit. And then I still had my fire extinguisher, my emergency exit doors to my right, behind me, to the left. And then I also had little nitrile gloves. So just to help be as cautious as I could, I had my dry absorption material off to the side here, along with shop vac and my broom as well, which is just over here. So going through the MSDS material safety data sheet, nothing was hazardous. Everything was diluted. And reading over that, the dry absorbent material was acceptable, and then discarding it appropriately. So I didn't feel like there was any concerns. As far as avoiding contamination, I disinfected the loops per the procedures, and then just waiting on the cool down. So I guess that's one thing I would note would be you have to be cautious that you give the appropriate amount of time for it to cool down. The 30 seconds is what it recommended. I could see that being a potential safety concern, just so that you don't like pre-ignite or burn anything. As far as accidentally contaminating your labware, so from the loops, contaminated it into the solution. That was a pretty obvious one, because if you overheated the loops, you would get you'd get material in your solution. So you're contaminated it that way, and then also you could tell just by not having a visible coloration if you didn't have enough of the solution or anything like that. So I isolated each loop per chemical, so there wasn't any concerns or issues with contamination. The one that I liked observing the most was probably the third one, the potassium chloride, just because the purple was a very obvious color. When you got into the sodium chloride, the yellow and the orange, I guess, as well for the calcium, you couldn't really see a real noticeable color. The lithium, I had the hardest time with the lithium, getting it to give visible results. And it was just making sure I had adequate amounts of solution, getting right to the base of the flame to try and ignite that solution. As far as determining the wavelength that the light observed, I tried to utilize this scale as much as possible. And then I also went just visible, like naked eye, and then I probably did each one 6 to 8 times, just trying to get accurate results. As far as a conclusion, I can craft based on the experiment. It was a fun experiment. It gives you a little bit more insight to things like fireworks and different colorations for flames. I know even at like Home Depot, I've seen logs that, they're supposed to be like a fun campfire log and they'll burn at different colors. And this helps explain it all, and kind of put two and two together. And I thought that was a lot of fun. Naturally, I wanted to go and as intense as possible. And, how could I get a non-diluted chemical to get a more visible result? But obviously, you have safety precautions that need to be taken for that. Discuss how I use the resources to supplement my knowledge for this activity. So I did go online and through the textbook and stuff like that to help break down kind of the chemical compositions, and especially when it came to the MSDS, I utilized the link in the module, and a lot of the safety data sheets, they weren't the exact same. You could tell there was certain criteria that had to be written and it had to be shown, but there was some stuff that wasn't like 100% night and day clear, and it was as far as like the symbols. So I think it was the lithium chloride. We have the diluted solution, but when you get to just straight non-diluted, then you implement symbols. And I think for one of the pre-lab quizzes, it asks you for a symbol on the lithium, and then the image doesn't populate. And so that was the only thing I had to kind of supplement my knowledge. I went and did a little bit of searching to find out what the true MSDS kind of was supposed to be. Let's see. As far as a particular resource, not necessarily. I use a lot of the lab given resources from the course, from what they recommend. And then textbook's been probably the most helpful, just trying to break it down. And then the resources with my class, they were just shared in the class, so I didn't feel like it was anything that they didn't already have access to. Let's see. So as far as critical thinking goes, the underlying chemistry principles applicable to both flame tests and atomic emission spectra, I guess that would go into kind of the wavelength for the individual chemical, and what they burn at. So how to make that connection, I guess, in my mind, you would have individual heat waves, I guess, and then the coloration based off of heat. And then if you, I guess, convert that into light, your wavelength, the speed of which that wavelength would travel would indicate visibly kind of the coloration of it. So when you get into your red coloration versus purple, red being 700 nanometers, purple being 300 nanometers, visibly you would have quite a bit of change on how, and I guess really how far and how visible that is if you have a very quick wave, which I drew that horribly, versus a very long wave. Something with a extremely short wave, to where if you get into purple 300 nanometers, it's going to be visibly very appealing, as long as you're close within direct kind of sight based on that measuring distance, versus something like red is going to not be as maybe visually appealing, but it's going to travel a lot further. So there's, I guess, some pros and cons to that. Things when you get to like lasers and red laser beams and how far they travel versus something like a purple or blue, it's going to take a little bit more power and, I guess, chemical composition that might not be as friendly or as healthy in order to get the same intensity at that given length. So hopefully I answered that kind of clearly, but that's how I would make that connection. So overall, very, very fun lab. I look forward to the rest of them. And hopefully I covered everything that I needed to. So thank you. And please let me know if I need to make any changes or adjustments. Bye.